So let's now discuss factors affecting enzyme action. There are three factors which affect enzyme activity. The first one is obviously substrate concentration, and the second one is temperature, and the third is pH. And as far as temperature and pH are concerned, in both the cases, for every enzyme there will be an optimum temperature or an optimum pH at which the enzyme activity will be maximum, and on either side the activity will be low. So it will be a bell-shaped curve. Yeah, for temperature and pH, for every enzyme there is an optimum temperature and an optimum pH at which the activity will be maximum. On either side it will be low. So this is about how temperature and pH can affect the rate of enzyme catalyzed chemical reaction. Now, what is the effect of substrate concentration on the rate of enzyme catalyzed chemical reaction? As you all know, as the substrate concentration increases, as the substrate concentration increases, what do you think will happen to the rate of enzyme catalyzed chemical reaction? That also increases linearly. But this linear increase happens only till a point, after which even if you increase the substrate concentration, the rate of the chemical reaction cannot increase. Why do you think it reaches a saturation point? Because at this point all the available enzymes would have got saturated with the available substrate. So beyond this point, even if you increase the substrate concentration, the rate cannot increase any further. Okay, so it reaches a saturation point. So this is about the effect of substrate concentration on the rate of chemical reaction. So that point wherein all the available enzyme binding sites have got saturated with the substrate, at that point the maximum velocity that is achieved will be called as a Vmax. The velocity that is achieved when all the available binding sites of the enzyme have got saturated with the substrate will be called as Vmax. But this Vmax is unattainable. Be it in vitro conditions or in vivo conditions, they have tried their maximum. They have increased the substrate concentration to how much ever possible, but they found out that the enzymes binding sites cannot get saturated because enzymes are required only in very minute quantities and they get recycled back and forth. Okay, so Vmax can never be achieved. Okay, so we have something called as half Vmax, and at half Vmax the substrate concentration is called as Km. So what is Km? Km is the substrate concentration at half maximal velocity. Do you understand this? So what are the three factors which affect enzyme catalyzed chemical reaction? Temperature and pH. For every enzyme there is an optimum temperature, optimum pH wherein the activity is maximum, and on either side it is low. Substrate concentration, as you increase the substrate concentration, the rate of the enzyme catalyzed chemical reaction also increases linearly till a point, beyond which even if you increase the substrate concentration, the rate cannot increase anymore, because at that point all the available binding sites get saturated with the substrate. That point wherein all the available enzymes binding sites have been saturated with the substrate, the velocity that is achieved is called as Vmax. But because enzymes are just catalysts which are required in minute quantities, and because enzymes get recycled every now and then, both in vitro conditions and in vivo conditions, we have never been able to reach Vmax. So to have something which is measurable, we have something called as half Vmax. And at half Vmax, the substrate concentration is called as Km. So what is Km? Km or Michelis constant. Okay, Km or Michelis constant is the substrate concentration at half maximal velocity. And about this I've already told you. What do you mean when you say that Km of an enzyme is high? If you say that Km of an enzyme is high, you mean to say you need to provide more substrate for the enzyme to reach half maximal velocity. Why do you have to provide more substrate? It is because the affinity of the enzyme for the substrate is low. So how is Km and affinity related? Km and affinity are inversely related. Higher the Km, lower will be the affinity of the enzyme for the substrate. So these are the two facts I want you to know about Km. What is Km? It's a substrate concentration at half maximal velocity. Higher Km means lower affinity. Okay. Now about Michaelis-Menten equation. So what is Michaelis-Menten equation? You need to know about this equation to find out enzyme inhibition type. Okay, to understand double reciprocal plot. So what is Michaelis-Menten equation? V is equal to V max into S by Km plus S. So what is Michaelis-Menten equation? Velocity V, that is the rate of enzyme catalyzed chemical reaction at any point of time, is equal to V max, that is a maximum velocity that is achievable, into substrate concentration by Km plus S. So what is the purpose of this equation? This equation is used to find out the velocity of an enzyme catalyzed chemical reaction at any point of time. Okay. Now, do you think this equation can be directly used? You cannot use this equation directly because this equation has got a term which is never measurable. You cannot measure Vmax, which means you can't use the equation directly. So, to be able to use this equation, we take reciprocal on both the sides. So, when you take reciprocal on both the sides, what will you get? 1 by V is equal to Km plus S divided by V max into S. Okay. Now, can we write the same equation as 1 by V is equal to Km by V max into 1 by S. There is a common denominator here which I am just splitting it. Okay. So, 1 by V is equal to Km by V max into S plus S by V max into S. So, we cancel these two. So, what is the equation we have? 1 by V is equal to Km by V max into 1 by S plus 1 by V max. Okay. And don't you think this is in the form of Y is equal to AX plus B? Yeah, this is in the form of Y is equal to AX plus B. What is Y is equal to AX plus B? It is equation of a straight line. This means if you draw a graph, this means if you draw a graph with 1 by V along y-axis and 1 by S along x-axis, you will get a straight line. Do you understand this? This means if you draw a graph with what? If you draw a graph with 1 by V along y-axis and 1 by S along x-axis, you will get a straight line. And for this straight line, if I want you to find out what is the y-intercept and what is the x-intercept, what do you mean by y-intercept and x-intercept? Y-intercept is the point at which it cuts the y-axis. Yeah. X-intercept is the point at which it cuts the x-axis. To find out y-intercept, you should put x is equal to 0. So, in this equation, for you to find out what is the y-intercept, you should put x is equal to 0. So, if this is put as 0, what is y equal to? 1 by V is equal to 1 by V max. Which means what is the y-intercept? The y-intercept is 1 by V max. So, this straight line cuts the y-intercept at 1 by V max. To find out what is the x-intercept, you should put y is equal to 0. So, if you put y is equal to 0, what happens to this equation? I am going to put this is equal to 0. So, 0 is equal to Km by V max into 1 by S plus 1 by V max. And if you rearrange this to the other side, what will you get? Minus 1 by V max is equal to Km by V max into 1 by S. cancel these two. Okay. So what do you get? You get 1 by S is equal to, 1 by S is equal to, you cross multiply this, it is minus 1 by Km. So what is the x-intercept? The x-intercept is minus 1 by Km. So if you extend the straight line and if you allow it to cut the x-axis, at what point will it cut the x-axis? It cuts at minus 1 by Km. This is called as double reciprocal plot. Why do you call it as double reciprocal plot? Because this plot is drawn with double reciprocals, right? Both along y-axis and along x-axis, it's reciprocals. Along y-axis, you have 1 by v. Along x-axis, you have 1 by s. So you call it as double reciprocal plot or Lineweaver Burke plot. This was the plot that was given in NEET 2020 question paper, and you were asked to find out what type of inhibition is it. Yeah, so it's Lineweaver Burke plot. So what are the facts you know about double reciprocal plot or Lineweaver Burke plot? It's a plot which is drawn with 1 by v along y-axis and 1 by s along x-axis. You get a straight line, and if you extend the straight line cuts the y-axis at 1 by v max and it cuts the x-axis as minus 1 by km. Okay. So I'm going to repeat all that I've told you so far about Lineweaver Burke plot. So how is Lineweaver Burke plot drawn? It's a plot that is drawn with what along y-axis? 1 by v along y-axis and 1 by s along x-axis. You definitely would get a straight line. And if you extend the straight line cuts the y-axis at 1 by v max and it cuts the x-axis at minus 1 by km. So what is the application of Lineweaver Burke plot? This plot can be used to find out Vmax. So how will you find out Vmax? At various substrate concentrations. Yeah, you start with 0.01 millimole per liter substrate concentration. You increase it to 0.05, 0.1, 0.2, 0.5 till 1. So at various substrate concentration, you analyze the rate of product formation. The rate of product formation would be V. So for various substrate concentration, you have V values. Take reciprocal. For various 1 by S, you have 1 by V. Now draw a graph with 1 by S along x-axis and 1 by V along y-axis. You get a straight line. You extend the straight line. You see the point at which it cuts the y-axis. That gives you 1 by V max. Take a reciprocal of it. That is the V max of your enzyme. So though Vmax cannot be measured, you can calculate it using Lineweaver Burke plot or double reciprocal plot. And you see the point at which it cuts the x-axis. That's going to be 1 by km. Take a reciprocal of it. Okay, so that's one application of Lineweaver Burke plot or double reciprocal plot. The other application is using this plot, you can find out what type of inhibition it is. Okay, you know, most of the pharmacological agents that are being used these days are inhibitors of one or the other enzyme in your body. Suppose you have found out a chemical substance which you think can inhibit, say, cholesterol ester transfer protein. Okay, you want to find out what type of inhibition it is before you can proclaim yourself to have found out something, right? So to find out what type of inhibition this inhibitor does, you have to use this Lineweaver Burke plot. Now you will have to know what are the types of inhibition. So there are two types of inhibition. One is reversible inhibition. The other one is irreversible inhibition. And I'm not going to talk about irreversible inhibition because in this case, the inhibitor substance irreversibly inhibits the enzyme. So we do not that commonly use such an inhibitor for a treatment. Because by mistake, if there is a toxic dosage, you can't reverse it. And the one drug which I can tell you as an irreversible inhibitor, which has got a pharmacological effect, is aspirin. You know, aspirin is acetyl salicylic acid. It acetylates and irreversibly inhibits cyclooxygenase enzyme. Yeah, that's an example for irreversible inhibition. And most of the pharmacological agents come under what type of inhibition? Reversible inhibition. Now, reversible inhibition is of three types. One is competitive inhibition. Second one is uncompetitive inhibition. Please, it's not non-competitive. Yeah, competitive inhibition, uncompetitive inhibition, and the third one is mixed inhibition. So, what is competitive inhibition? The normal chemical reaction is enzyme react with substrate, and this enzyme and substrate together form enzyme substrate complex. And this enzyme substrate complex dissociates to give either enzyme and substrate back, or they give rise to enzyme and product. This is a normal reaction. Normally, in an enzyme catalyzed chemical reaction, enzyme and substrate together form enzyme substrate complex, and that enzyme substrate complex either break to give enzyme and substrate, or they form enzyme and product. Now, what is a competitive inhibitor? A competitive inhibitor competes with the substrate. Yeah, a competitive inhibitor is a substrate analog, and it competes with the substrate to bind to the enzyme, and it forms an enzyme inhibitor complex. And this enzyme inhibitor complex will not allow the product to be formed. Okay, which means in the presence of a competitive inhibitor, the probability that the substrate binds to the enzyme is reduced. The probability that enzyme substrate complex is formed is reduced. The probability that product is formed is reduced. So, it's just a reduction in the probability. In that case, tell me what will happen when you increase the substrate concentration. Yeah, when you increase the substrate concentration, the competition between inhibitor and substrate is favored towards substrate. So, when you have more substrate, the probability that the substrate binds to the enzyme is more, enzyme substrate complex is formed, and product is formed. Which means if it's a competitive inhibition, you can overcome the competitive inhibition by increasing the substrate concentration. Thereby, you can achieve Vmax. One way or the other, you can reach Vmax. So, in the presence of competitive inhibition, Vmax is normal. But to achieve that Vmax, you have to increase the substrate concentration. So, what happens to Km? What is Km? I told you. Km is the substrate concentration at half maximal velocity. To achieve half maximal velocity, you had to increase the substrate concentration. So, what happens to Km? Km is increased. So, in the presence of a competitive inhibitor, Vmax is normal, but Km is increased. This will be evident in Lineweaver Burke plot. Okay. Suppose you found out a competitive inhibitor for cholesterol ester transfer protein. So, to find out what type of inhibition is it, first you take cholesterol ester transfer protein and you draw its Lineweaver Burke plot. How is it drawn? It's a repetition. Try to tell to yourself how is it drawn. 1 by V along y-axis and 1 by S along x-axis. You get a straight line, and the point at which it cuts the y-axis is 1 by Vmax. The point at which it cuts the x-axis is minus 1 by Km. This is for the normal enzyme. Now, to this enzyme and substrate, you add the inhibitor which you have found. And you find out after I add the inhibitor, what happens to the Lineweaver Burke plot. Suppose the Lineweaver Burke plot is like this. After adding an inhibitor, the Lineweaver Burke plot is like this. What does it mean? 1 by Vmax is normal, right? What has happened to 1 by Km? It has gone close to 0. So, 1 by Km is reduced. So, Km is increased. So, if you see one such a plot, it means it's a competitive inhibitor. So, you should remember that in the presence of a competitive inhibitor, Vmax remains normal like this and Km is increased, or 1 by Km is decreased. Okay, so this is about competitive inhibition. Now, what is an uncompetitive inhibitor? So, what is a normal enzyme catalyzed chemical reaction? Again, Normally, enzyme reacts with substrate to form enzyme-substrate complex. This enzyme-substrate complex dissociates to form enzyme and substrate, or it forms enzyme and product. Now, what does an uncompetitive inhibitor do? Uncompetitive inhibitor reacts with the enzyme-substrate complex. Competitive inhibitor reacts with the free enzyme. Uncompetitive inhibitor reacts with the enzyme-substrate complex to form an enzyme-substrate inhibitor complex which will not allow product to be formed. Okay, this is how uncompetitive inhibitor works. In this case, what will happen if you increase the substrate concentration? How much ever you increase a substrate concentration, all these substrate would become enzyme substrate complex, and all these enzyme substrate complex will form enzyme substrate inhibitor complex, and product is not going to be formed. So, how much ever you increase a substrate concentration, you are not able to overcome this inhibition. So, Vmax is definitely reduced. Do you understand this? In the presence of an uncompetitive inhibitor, Vmax is reduced. And what happens in this condition? In this condition, because this inhibitor always diverts this enzyme substrate complex to form something else, this side of the equilibrium concentration is kept low. So, if this side of the equilibrium concentration is kept low, the equilibrium gets shifted towards forming enzyme substrate complex. And for forming enzyme substrate complex, enzyme and substrate react together more avidly. So, affinity is increased. Affinity of the enzyme for the substrate is increased. If affinity is increased, what will happen to Km? Km is also low. Okay, so I am repeating this. Uncompetitive inhibitor reacts with the enzyme substrate complex, forming enzyme substrate inhibitor complex. And in this case, how much ever you increase the substrate concentration, the product will not be formed. So, Vmax is reduced. But in this case, because the inhibitor always diverts enzyme substrate complex to form something else, enzyme substrate concentration is kept low. And in equilibrium, in an equilibrium reaction, if one side of the equilibrium concentration is low, the equilibrium gets shifted towards that side. And to form it, enzyme and substrate react together more avidly. So, affinity increases and Km decreases. So, in the presence of uncompetitive inhibitor, parallel alteration, both Vmax and Km will be low. So, what happens when you draw a Lineweaver Burke plot? 1 by V along y-axis, 1 by S along x-axis, you get a straight line. That line cuts the y-axis at 1 by Vmax. It cuts the x-axis at minus 1 by Km. And if it's an uncompetitive inhibitor, if it's an uncompetitive inhibitor, because Vmax is reduced, 1 by Vmax will be increased. 1 by Vmax will be increased. Km is reduced, so 1 by Km will be increased. So, line will be parallelly shifted above. So, if you find parallelly shifted lines, it means it's an uncompetitive inhibitor. Okay, if both the values get altered towards the same direction, Vmax is low, Km is also low, the line is shifted parallelly above, it means it's uncompetitive inhibition. Now, what is mixed inhibition? Normally, enzyme reacts with substrate to form enzyme-substrate complex that becomes either enzyme and substrate, or it becomes enzyme and product. Now, in the presence of a mixed inhibitor, the mixed inhibitor reacts both the free enzyme as well as the enzyme-substrate complex. Okay. Competitive inhibitor, it reacts only with free enzyme. Uncompetitive inhibitor reacts only with enzyme-substrate complex. Mixed inhibition, it reacts with both free enzyme and enzyme substrate complex. In that case, tell me what happens to Vmax. Whatever you do, you increase the substrate concentration, you do whatever you like, you cannot overcome this inhibition. So, Vmax is low. Definitely Vmax is low. But in this inhibition, there is something which is competing with the substrate to bind to the enzyme. There is something which is competing with the substrate to bind to the enzyme. So the probability that the substrate can bind to the enzyme is less. Affinity is less. So Km is increased. So if both Vmax value and Km value are altered in the wrong direction, Vmax is supposed to be high, but here Vmax is low. Km is supposed to be low, but here Km is high. So if both the values are altered in the wrong direction, it is a mixed inhibitor. Okay. So what happens when you draw a Lineweaver Burke plot? 1 by V, 1 by S. Cuts y-axis at 1 by Vmax. This is a normal Lineweaver Burke plot of the enzyme. Now what happens in the presence of a mixed inhibitor? The mixed inhibitor reduces Vmax, so 1 by Vmax is high. Yeah, 1 by Vmax is high. It increases Km, so 1 by Km is reduced. So this is the Lineweaver Burke plot which you will get in the case of mixed inhibition. If both the values are altered in the wrong direction, it's a mixed inhibition. Now there is a special type of mixed inhibition. Listen to this. There is a special type of mixed inhibition called as a non-competitive inhibition. It is a non-competitive inhibition wherein the inhibitor binds with both the free enzyme and the enzyme substrate complex with the same affinity. Yeah, it binds to both the free enzyme and the enzyme substrate complex with the same affinity. In that case, Km is unaltered. You don't have to worry about the mathematical basis of this. It's purely mathematical. It involves a derivation. All that I want you to know is non-competitive inhibition is a type of mixed inhibition wherein the inhibitor binds to free enzyme and enzyme substrate complex with the same affinity. And in that case, Km is unaltered and Bmax is low. Okay. So suppose this pink color represents Lineweaver Burke plot of a non-competitive inhibitor. I said Km is unaltered. Yeah, Vmax is low in the sense 1 by Vmax is high. So this is how the line would be. So if you see a line of this type, what type of inhibition is it? It's a non-competitive inhibition. So I'm going to show you a tabular column, draw a tabular column to tell you or to make it clear about what happens in all these types of inhibitors. So what are the facts you need to know to answer an MCQ on inhibition? You need to know about 4 types of inhibition. And in all the 4 types of inhibition, you need to know what happens to Km, what happens to Vmax. So first column is type of inhibition. Yes. First column is type of inhibition. Second column is what happens to Km. Third column is what happens to Vmax. So what's the first type of inhibition? Competitive inhibition. And competitive inhibition is just a competition. It's just a reduction in probability which can be overcome by increasing the substrate concentration. So Vmax remains normal. But to reach the Vmax, you have to increase the substrate concentration. So Km is increased. Okay. Now what happens in uncompetitive inhibition? For uncompetitive, remember parallel lines. So both Vmax and Km are altered parallelly. And you know in uncompetitive inhibition, Vmax is reduced. Km is also reduced. Mixed inhibition, both values get altered in the wrong direction. So Vmax is reduced and Km is increased. Non-competitive inhibition is a special type of mixed inhibition wherein Km is normal and Vmax is low. Okay, so if you can remember this tabular column, you can answer any question on inhibition. You have to look at the Lineweaver Burke plot. See where is the normal Km, where is the Vmax. See what happens in the presence of inhibitor. Find out what kind of variation is observed and then say what type of inhibition it is. On a go, if you want to answer, if it's a parallelly shifted line, it's uncompetitive inhibition. That's most commonly asked.